Here we come to A-Level Physics 2010 question 8. So we have two identical small spheres P and Q connected by light strings to a fixed point O. So the distance OP and PQ are same length. They perform uniform circular motion about O with the same period. Okay, let's focus with the same period. What does that mean? If period is the same, that means omega will also be the same. So they have the same omega, same angular speed. So now we denote T1 and T2 to denote the tension in frets OP and PQ respectively. I would like to illustrate it by drawing the free body diagram for P and Q respectively. So we have P and Q. So P is pulled to the left hand side by T1 and pulled to the right hand side by T2, and Q is pulled to the left hand side by T2. So we know that F is equals to mr omega squared. Now in this case, we are not using mv squared over r because they do not have the same v. So we cannot compare the two objects using this equation. So this is wrong. Here we would use F equals mr omega squared on each of the object. Now just to remind you, this F is actually the net force. So for example, let's take a look at P. F net equals mr omega squared. Mr omega squared. For F net, we have to write T1 minus T2 will be equals to mr, the radius r. Okay, I just call it r. And it will be omega squared. And for Q, I do the same thing. The net force on Q is T2. The mass is the same. Note that the radius of its circular path is 2r. And it has the same omega squared. Now I am going to put this equation into the left hand side. So we would got T1 minus 2 mr omega squared equals mr omega squared. We would have T1 equals 3 mr omega squared. And we put this equation and this equation together by doing division. T1 divided by T2 would be equals to 3 mr omega squared over 2 mr omega squared. You see that these all cancel out. So T1 to T2 is equals to 3